we're going to do the solutions to problem set 3 here, which are on complex numbers. So what is the square root of -5? That's just the square root of 5 times I, where I is the square root of -1. Add 3 plus 4i to 1 minus I. So, these questions are just introducing how we manipulate complex numbers, how we write them down. And the answer is 4 plus 3i. So a complex number has a real part. So in this case, be 3 in 3 plus 4i and 1 in 1 minus I. And a complex imaginary part. So a part which is multiplied by I. And the way you add them is you just add the two real parts. So here you have 3 plus 1 to get 4, 3 plus 1 to get 4, and you add the imaginary parts. So 4i minus I is 3i. Multiply them. Well, here you multiply 1 by 3 plus 4i and minus I by 3 plus 4i to get 3 plus 4i. That's if you multiply 1 by 3 plus 4i minus I times 3 plus 4i. So you're multiplying it by 1 minus I, so that second part is that minus I part we have, and we multiply that by 3 plus 4i. So we just multiply things as usual. So we have 3 So we group these into real and imaginary parts. So we look at the real part first. We have a 3 there. That's real. And then if we multiply I by 4i, well, that's minus I by 4i, we end up with minus 4i times I. And that's a real number because I squared is equal to minus 1. Now the imaginary part, well, we have plus 4i, and 3 multiplied by minus I gives us minus 3i. So we add these terms, we end up with 7, because that's 3 minus 4, I squared is minus 1, so this becomes plus 4, and 3 plus 4 is equal to 7. We have minus 3i plus 4i, that gives us plus I. So we just have to remember that I squared is minus 1, and otherwise we just multiply things as we normally would. Divide 3 plus 4i by 1 minus I. This is the trickiest operation, so unless you study, this will be the question that most people would get stumped by. But it's basically like fractions. So we have 3 plus 4i, and we want to divide that by 1 minus I. So then we're going, how do I do that? I mean, that's just, I'll just leave it like this. The trick is to multiply top and bottom by 1 plus I, as we've done there. And the reason we do that is that if we multiply 1 minus I by 1 plus I, we end up with a real number. So we just end up with a 2 below. And on top, well, we've done multiplication. So we just multiply that out and we end up with 7I minus 1. I'll just actually check that. So 4I times 1 will give us 4I. I multiplied by 3 will give us 3I. So we'll end up with 7I. And real number wise, well, 3 times 1 will give us 3. 4I times I will give us minus 4. So yeah, we'll end up with minus 1. So you can do many examples. You know, you can write loads of complex numbers, add them, multiply them, but it's the same process. And you'd want to practice yourself to kind of see that, oh, I've got it, as opposed to just watching someone else do it and nodding your head going, oh yeah, that makes sense. Determine the modulus of 3 plus 4I. Well, that's just, you take the coefficients, so here 3 and 4, you square them and add them, and then you take the square root of the total. So in this case, 3 squared plus 4 squared, well, that's equal to 5 squared. So we want the square root of 5 squared, well, that's equal to 5. The modulus kind of makes more intuitive sense when you plot it on the Argand diagram. That's the distance, or the length of the line from the origin to that complex number. So if we plot 3 plus 4I on an Argand diagram and we draw a line from that to 0, 0, the length of that is equal to the modulus. What is the complex conjugate of 3 plus 4I? That's 3 minus 4I. So the complex conjugate is you just change the sign of the coefficient in front of the complex number. So the real number part is left the same, the complex number part, the sign is flipped. And the reason you want to do that is, well, kind of we saw when we were doing division. So a number multiplied by its complex conjugate gives you a real number. So multiply 3 plus 4I by its conjugate. So, you know, here we just wanted you to work out what the conjugate of a number was. Here we were looking at multiplying something by its complex conjugate. So when you do that, you end up with the modulus squared. So it's more introducing terms. Why would you want to do that? It would depend on the problem you're working on. But from our point of view here, it's one of the questions that we can ask you when it comes to complex numbers. So all you need to know is this. You know, I mean, getting the complex conjugate is incredibly easy. Just change that sign. Multiplying them, well, that's, once you know how to multiply complex numbers, you know how to multiply them. The modulus, well, if you've done trigonometry, Pythagoras, you know that the distance from 0, 0 to 3, 4 is this. So that's the vast bulk of what we need to do with complex numbers. Why do you want to know them? Well, it extends, for example, well, it extends the equations that we can solve. By doing complex numbers, we can solve any quadratic equation, as opposed to, you know, being stuck, going, oh, this equation has no solution, by which we mean this equation has no real solution. So we just have the last bit to do with Argand diagrams, which I'm not going to do within this system, but I'll just write it out on a pad. But so the basic, so all we need to do is plot 5 minus 2i on an Argand diagram. Well, remember, an Argand diagram, you just have, instead of an x and a y axis, you have a real axis and an imaginary one. So we just plot the point 5 minus 2. Plot I times that. Well, multiply I by 5 minus 2i, you end up with 5i plus 2. Now plot that on the Argand diagram. Pick a complex number yourself, plot it, and it multiplied by I. So think of a complex number, say 1 minus I to keep it simple. Plot it. So you plot imaginary axis minus I, real axis 1. Plot that on the Argand diagram, multiply that by I, plot that. And that's all we need to do. In an Argand diagram, it's like a normal coordinate diagram, except we have a real axis and an imaginary one. So this will be, say, I, 2i, 3i, 4i, and so on. This will be minus I, minus 2i, minus 3i, minus 4i. And this would be on the real axis 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. So if you want to plot 5 minus 2i, the real part is 5, so 1, 2, 3, 4, 5, and that's 5. Minus 2i, that's minus I, minus 2i. So that would be 5 minus 2i. So next we want I multiplied by that. So I'll just work that out. I multiplied by 5 minus 2i is 5i. So then 1, 2, 3, 4, so that would be 5i. And minus 2i times I would be, well, I squared will give us minus 1, so I'll end up with 2. So the real number is going to be 2. So it's going to be 2 5i. You see the 5 multiplied by I became 5i. The minus 2i times I became minus 2i squared. I squared is minus 1, so that becomes 2. Now I said think of any number, so say we just pick 0 comma or 2 comma 0. So it's only a real number. If I multiply that by I, I'll end up with 0 comma 2i. Because there's no imaginary component there, so it's just 0. When I multiply 0 by I end up with 0. The reason I wanted to put another example was that idea of if you multiply a number by I, you rotate it. So if I multiply 0 comma 2i by I again, I'll end up with 0 minus 2, or minus 2 on the real axis, because 2i times I becomes minus 2, and 0 times I remains a 0. So this number multiplied by I rotates it by 90 degrees, multiplied by I again, I rotate it by 90 degrees. So that's plotting complex numbers on an Argand diagram. And thing I didn't mention would be, so if I worked out the modulus, that is the length, the distance from here to the origin. Remember, if you have any questions, put them in comments in Facebook or below the video.